Hello and welcome to the webinar. My name is John Sutton and I'm an infrastructure security engineer with Base2 Solutions. In this video, I'm going to be talking about digital privacy. It's something I am incredibly passionate about and love researching and learning about. Today, we'll find out how companies are tying data to people, see what tracking networks look like, peer into the world of targeting, brokers, and real-time bidding, and lastly, find out what we can do to fight back. When thinking about entities who stand to benefit or profit from obtaining information about us, we can place each in one of three categories: corporations, governments, and cybercriminals. I'm going to be focusing this talk on corporations because it is arguably the most prevalent and most often the most misunderstood. So how do these corporations monetize our information, and what do they know about us? Let's use Google for an example. As you can see, Google knows an alarming amount about you and I, much of which could be incredibly valuable to third parties who are trying to predict what we're most likely to purchase next, whether that be a burrito for dinner or homeowners insurance. So how is Google obtaining all this information? Through the use of trackers. A tracker is a script on a website designed to collect data points about your preferences and who you are as you interact with their site. Trackers can fall into one of two categories: first-party trackers and third-party trackers. First-party tracking scripts are placed purposefully by the website you're on. Third-party tracking scripts may be from a website you've never visited. First-party trackers are used to help make your web experience better. They remember what kind of browser you have so the page will load more efficiently next time, or store a session cookie so you don't have to log in every single time you visit the page. Most third-party tracking is designed to build profiles of real people. That means every time a tracker collects a piece of information, it needs an identifier, something it can use to tie that information to a particular person. To keep track of who's who, trackers need identifiers that are unique, persistent, and available. Trackers can combine multiple weak identifiers to create a single strong one. So let's talk about these identifiers. This table gives a brief overview of identifiers and how unique, persistent, and available each type of identifier is. For the sake of time, I'm only going to talk about identifiers when browsing from the web from a computer, but there are other identifiers in real life like automatic license plate readers, facial recognition, speech recognition, and things like that. If we look at this list, this is exactly why VPNs are nowhere near as effective as people think they are. Out of all these web identifiers that websites are collecting from us, a VPN is only obscuring one: your IP address. Unless we are taking proactive measures to cover other web identifiers, we are not browsing the web anonymously when we're on a VPN. I want to talk about each of these identifiers, but before I do, I think it would be beneficial if we all had a general understanding of what happens when we visit a website from our computer. Browsers are the main way most of us interact with the web. Each time you visit a website, code on that site may cause your browser to make dozens or even hundreds of requests to hidden third parties. Each request contains several pieces of information that can be used to track you. Almost every piece of data transmitted between your browser and the servers of the websites you interact with occurs in the form of an HTTP request. Basically, your browser asks the web server for content by sending it a particular URL. The web server can respond with content, like text or an image, or with a simple acknowledgement that it received your request. It can also respond with a cookie, which can contain a unique identifier for tracking purposes. The URL itself contains a few different pieces of information. First is the domain, like example.com. This tells your browser which server to connect to. Next is the path, a string at the end of the domain, like /section.html. The server at example.com chooses how to interpret the path, but it usually specifies a piece of content to serve. Finally, some URLs have parameters at the end. The parameters usually carry extra information about the request, including queries made by the user, content about the page, and tracking identifiers. In this example, although the user has navigated to fafsa.gov, the page triggers a third-party request to facebook.com in the background. But the URL isn't the only information that gets sent to the receiving server, though. There are also HTTP headers, which contain extra information about the request, like your device's language, security settings, the referring URL, and cookies. For example, the user agent header identifies your browser type, version, operating system, and shared encryption state. Some requests contain even more configurable information in the form of post data. Post requests are a way for websites to share chunks of data that are too large or unwieldy to fit in a URL. Okay, so now that we know how web requests work, let's go back to the list of identifiers I showed earlier, starting off with cookies. The most common tool for third-party tracking is the HTTP cookie. A cookie is a small piece of text that is stored in your browser, associated with a particular domain. Cookies were invented to help website owners determine whether a user had visited their site before, which makes them ideal for behavioral tracking. Here's how they work. The first time your browser makes a request to a domain, like facebook.com, for example, the server can attach a set cookie header to its reply. This will tell your browser to store whatever value the website wants. Then, every time your browser makes a request to facebook.com in the future, it sends along the cookie that was set earlier. That way, every time Facebook gets a request, it knows which individual user or device it's coming from. Cookies are also the reason you don't have to log in every single time you visit a website, as well as the reason your cart doesn't empty if you leave a website in the middle of shopping. Cookies are just a means of sharing information from your browser to the website you are visiting. However, they are designed to be able to carry tracking information, and third-party tracking is their most notorious use. The problem with cookies is that now when you connect to a different website that has a Facebook tracker enabled, Facebook knows exactly who you are and how you're interacting with that site, what you're looking at, what you purchase, what you don't purchase. Luckily, we have a good deal of control over how our browsers handle cookies. Every major browser has an optional setting to disable third-party cookies, and Safari and Firefox have recently started restricting access to third-party cookies for our domains from known tracking companies, and we can always block cookies themselves with browsers extensions. Cookies are always unique, and they normally persist until a user manually clears them. Let's talk about your IP address. Each request you make over the internet contains your IP address, a temporary identifier that's unique to your device or the network you're on. Just like the post office needs a to and from address on an envelope, internet service providers need a to and from IP address to accurately route traffic across the web. Although it is unique, it is not necessarily persistent. Your IP address changes every time you move to a new network, for example, from your home network to work or to a coffee shop. Thanks to the way IP addresses work, it may even change if you stay connected to the same network. The next identifier is TLS state. When you connect to a server over HTTPS, your browser starts a new TLS session with the server. Setting up this encryption is very resource intensive, so servers don't like to do it more often than they have to. Instead of performing a full cryptographic handshake between the server and your browser every time you reconnect, the server can send your browser a session ticket that encodes some of the shared encryption state. The next time you connect to the same server, your browser sends a session ticket, allowing both parties to skip the handshake. The only problem with this is that the session ticket can be exploited by trackers as a unique identifier. The next identifier is browser local storage and iframes. Local storage is a way for websites to store data in a browser for long periods of time. Local storage can help a web-based text editor save your settings or allow an online game to save your progress. Like cookies, local storage allows third-party trackers to create and save unique identifiers in your browser. Also like cookies, data in local storage is associated with a specific domain. This means if example.com sets a value in your browser, only example.com web pages and example.com's iframes can access it. An iframe is like a small web page within a web page. Inside an iframe, a third-party domain can do almost everything a first-party domain can do. For example, YouTube videos are built using iframes. Every time you see a YouTube video on a site other than YouTube, it's running inside a small page within a page. For the most part, your browser treats the YouTube iframe like a full-fledged web page, giving it permission to read and write to YouTube's local storage area in your browser. Sure enough, YouTube uses that storage to save a unique device identifier and track users on any page with an embedded video. This local storage data is unique, and they persist until a user manually clears their browser storage. The last identifier on the list is called browser fingerprinting. There are several properties of your web browser and computer that a website can observe when you visit. This may be slightly different from other browsers or computers, which can be a way to recognize you even if you don't log in, even if your computer doesn't save a cookie, and even if you connect to the internet from a different network in the future. For example, you might be the only person who visits a particular website from a device set to a particular language with a particular screen size and using a particular web browser version. Then the site could realize that it's you whenever you visit, even if you don't do anything else to reveal your identity. Fingerprints are often, but not always, unique. Some browsers, like Tor and Safari, are specifically designed so that their users are more likely to look the same, which removes or limits the effectiveness of browser fingerprinting. Browser fingerprints tend to persist as long as the user has the same hardware and software. There's no setting you can fiddle with to reset your fingerprint, and fingerprints are usually available to any third parties who can run JavaScript in your browser. Okay, now that we have a good understanding of the identifiers being used, let's talk about what these tracking networks look like. The dominant force behind third-party tracking is the advertising industry. So it's no surprise that online ads are one of the primary vectors for data collection. In the simplest model, a single third-party ad network serves ads on a number of websites. Each publisher that works with the ad network must include a small snippet of code on their website that will load an ad from the ad server. This triggers a request to the ad server each time a user visits one of the corresponding sites, which lets the ad server set third-party cookies into users' browsers and track their activity across the network. Tracking code often isn't associated with anything visible to users, like a third-party ad. On the web, a significant portion of tracking happens via invisible one-by-one pixel images that exist only to trigger requests to the trackers. These tracking pixels are used by many of the most prolific data collectors on the web, including Google Analytics, Facebook, and Amazon. When website owners install a third party's tracking pixel, they usually do so in exchange for access to some of the data the third parties collect. For example, Google Analytics and Chartbeat use pixels to collect information and offer website owners and publishers insights about what kinds of people are visiting their sites. Social media companies provide a variety of services to websites, such as Facebook like buttons and Twitter share buttons. These are often pitched as ways for publishers to improve traffic numbers on their web platforms, as well as their presence on social media. Like and share buttons can be used for tracking in the same way that pixels can. The button is really an embedded image which triggers a request to the social media company's server. The biggest companies, Facebook and Google in particular, offer account management or single sign-on services to smaller companies, like Log On with Google. These services are attractive to publishers for a few reasons. One, websites and apps can offload the work of managing user accounts to the big companies. And two, users have fewer username and password pairs to remember and less frequently go through annoying sign-up login flows. The problem is that these single sign-on services allow login providers to act as a third party and track their users' activity on all the services they log into. Login services are more reliable trackers than pixels or other simple widgets because they force users to confirm their identity. CAPTCHAs are a technology that attempts to separate users from robots. Publishers install CAPTCHAs on pages where they want to be particularly careful about blocking automated traffic, like sign-up forms and pages that serve large files. Google's reCAPTCHA is the most popular CAPTCHA technology on the web. Every time you connect to a site that uses reCAPTCHA, your browser connects to Google in order to load the CAPTCHA resources and shares all associated cookies with Google. This means that its CAPTCHA network is another source of data that Google can use to profile users. So we know how the data is collected, but where does all this data go? Most trackers don't collect every piece of information by themselves. Instead, companies work together, collecting data for themselves and sharing it with each other. Sometimes, companies with information about the same individual will combine it only briefly to determine which advertiser will serve which ad to that person. In other cases, companies base their entire business model on collecting and selling data about individuals they never interact with. This section will explore how personal information gets shared and where it goes. Real-time bidding is the system that publishers and advertisers use to serve targeted ads. An advertiser pays an ad network for the right to show you an ad, and the ad network pays the publisher of the web page where you saw the ad. Before that can happen, the publisher and the ad network have to decide which ad to show. To do so, they conduct a milliseconds-long auction in which the auctioneer offers up a user's personal information, and then software on dozens of corporate servers bid on the right to that user's attention. First, data flows from your browser to the ad networks, also known as supply-side platforms. Each SSP receives your identifying information, usually in the form of a cookie, and generates a bid request based on what it knows about your past behavior. Next, the SSP sends this bid request to each of the dozens of advertisers who have expressed interest in showing ads. And finally, the advertisers look at your information, decide whether they'd like to advertise to you and which ad they want to show, then respond to the SSP with a bid. The SSP then determines who won the auction and displays the winner's ad on the publisher's webpage. All the information in the bid request is shared before any money changes hands. Advertisers who don't win the auction still receive the user's personal information. This enables something called shadow bidding. Certain companies may pretend to be interested in buying impressions, but intentionally bid to lose in each auction with the goal of collecting as much data as possible, as cheaply as possible. During the bidding process, advertisers and the demand-side platforms they work with can use third-party data brokers to augment their profiles of individual users. These data brokers sell data about individuals based on the identifiers and demographics included in a bid request. In other words, an advertiser can share a user ID with a data broker and receive that user's behavioral profile in return. From the perspective of the user who visited the page, real-time bidding causes two sets of privacy invasions. First, before they visited the page, an array of companies tracked their personal information and merged it all into a sophisticated profile about them. Then, during the bidding process, a different set of companies used that profile to decide how much to bid for the ad impression. Secondly, as a result of the user's visit to the page, the real-time bidding participants harvest additional information from the visiting user. That information is ingested into the user's old profile to be used during subsequent real-time bids triggered by their next page visits. Thus, real-time bidding is both a cause of tracking and a means of tracking. Cookie syncing is a method that web trackers use to link cookies with one another and combine the data one company has about a user with the data another company might have. One tracking domain triggers a request to another tracker. In the request, the first tracker sends a copy of its own tracking cookie. The second tracker gets both its own cookie and the cookie from the first tracker. This allows it to compare notes with the other tracker while building up its profile of the user. Cookie sharing is commonly used as part of real-time bidding. In a bid request, the SSP shares its own cookie ID with all the potential bidders. Without syncing, the demand-side platforms might have their own profiles about the users linked to their own cookie IDs. A DSP might not know that user ABC from Google's ad network is the same as its own user XYZ. Cookie syncing lets them be sure of that. Your data also goes to data brokers. Data brokers are companies that collect, aggregate, process, and sell data. Often, data brokers have no direct relationships with users at all, and the people about whom they sell data might not even be aware they exist. Data brokers purchase information from a variety of smaller companies, including retailers, financial companies, medical research companies, online advertisers, cellular providers, IoT device manufacturers, and local governments. They then sell data or data-powered services to advertisers, real estate agents, market research companies, colleges, and governments. By far, the biggest and most visible data consumers are targeted advertisers. Targeted advertising allows advertisers to reach users based on demographics, psychological characteristics, and other traits. The biggest data collectors are also the biggest targeted advertisers. Together, Google and Facebook control almost 60% of the digital ad market in the US. Some advertisers want to reach users on Facebook or Google, but don't want to use the big companies' proprietary targeting techniques. Instead, they can buy lists of contact information from data brokers, then upload those lists directly to Facebook or Google, who will reach those users across all their platforms. Targeting platforms like Google and Facebook do not allow advertisers to target users of particular ethnicities with ads for jobs, housing, or credit. However, advertisers can buy demographic information about individuals from other data brokers, upload a list of names who happen to be from the same racial group, and have that platform target those people directly. Companies aren't the only entities that try to benefit from data collection and targeted advertising. Cambridge Analytica used personal data to estimate what they called psychographics for millions of potential voters, then used that data to help political campaigns. In 2018, the group Catholic Vote used cell phone location data to determine who had been inside a Catholic church, then targeted them with get out and vote ads. Anti-abortion groups used similar geofencing technology to target ads to women while they were at abortion clinics. And those incidents are not isolated. Many politicians around the country have used open voter registration data to target voters. The Democratic National Committee is reportedly investing heavily in its data warehousing ahead of the 2020 election. And Deep Root Analytics, a consulting firm for the Republican Party, who is the source of the largest data breach of U.S. voter data in history, is collecting names, registration details, and modeled ethnicity and religion data about nearly 200 million Americans. Debt collectors, bounty hunters, and repossession agencies all purchase and use location data from a number of sources. The bail bond company Captira sold location data gathered from cell phones and automatic license plate readers to bounty hunters for as little as $7.50. And thousands of apps collect consensual location data using GPS permissions, then sell that data to downstream aggregators. This data can be used to locate fugitives, debtors, and those who have not kept up with their car payments. And as investigations have shown, it can also be purchased and abused by nearly anyone. The government also purchases data from the private sector for all manners of reasons. For example, ICE bought automatic license plate reader data from Vigilant to help locate people the agency intends to deport. Government agencies contract with data brokers for a myriad of reasons, including determining eligibility for human services to tax collection. And of course, national security surveillance often rests on the data mining of private companies' reservoirs of consumer data. For example, as part of the PRISM program revealed by Edward Snowden, the NSA collected personal data directly from Google, YouTube, Facebook, and Yahoo. With thousands of independent actors using hundreds of different techniques, corporate surveillance is widespread and well-funded. While there's no switch to flip that can prevent every method of tracking, there's still a lot that you can do to take back your privacy. In this section, we'll go over some of the ways that privacy-conscious users can avoid and disrupt third-party tracking. There are several ways to limit your exposure to tracking on the web. First, your choice of browser matters. Apple's Safari takes active measures against the most common forms of tracking, including third-party cookies, first-to-third-party cookie sharing, and fingerprinting. Firefox blocks third-party cookies from known trackers by default, and Firefox private browsing mode will block requests to trackers altogether. Browser extensions like the Electronic Frontier Foundation's Privacy Badger and uBlock Origin offer another layer of protection. In particular, Privacy Badger learns to block trackers using heuristics, which means it might catch new or uncommon trackers that static list-based blockers miss. And while Google Chrome does not block any tracking behavior by default, installing Privacy Badger or another tracker blocking extension in Chrome will allow you to use it with relatively little exposure to tracking. If you'd like to go the extra mile and are comfortable with tinkering, you can install a network-level filter in your home. Pi-hole filters all traffic on a local network at the DNS level. It acts as a personal DNS server, rejecting requests to domains which are known to host trackers. Pi-hole is great because it blocks tracking requests coming from devices which are otherwise difficult to configure, like smart TVs, gaming consoles, and other IoT devices. For people who want to reduce their exposure as much as possible, the Tor browser is the gold standard for privacy. Tor uses an onion routing service to totally mask its users' IP addresses, and it takes aggressive steps to reduce fingerprinting. It completely rejects TLS session tickets and clears cookies at the end of each session. Unfortunately, browsing the web with Tor is not for everyone. It significantly slows down traffic, so pages take much longer to load, and streaming video or other real-time content is very difficult. Worse, much of the modern web relies on invisible CAPTCHAs that block or throttle traffic from sources deemed suspicious. Traffic from Tor is frequently classified as high risk, so doing something as simple as a Google search with a Tor can trigger CAPTCHA tests. And since Tor is a public network which attackers also use, some websites will block Tor visitors altogether. Some jurisdictions have laws to protect users from tracking. The General Data Protection Regulation, or GDPR, in the European Union gives those it covers the right to access and delete information that's been collected about them. In the US, varying state and federal laws offer specific protections to some. Vermont's data privacy laws bring transparency to data brokers. The Illinois Biometric Information Protection Act requires companies to get consent from users before collecting or sharing biometric identifiers. This year, the California Consumer Privacy Act started to take effect, giving users there the right to access their personal information, delete it, and opt out of its sale. At the federal level, some information is protected by laws like HIPAA. However, these sector-specific federal statutes apply only to specific types of information about specific types of people when held by specific businesses. So there are a lot of loopholes. To make a long story very short, most third-party data collection in the US is unregulated. And I think that we should have the right to know what personal information is collected about us and what is done with it. We should be free from corporate processing of our data unless we give our informed opt-in consent, and companies should be held accountable when they misuse or mishandle our data. The first step is shedding light on this massive, complex platform. Once we understand what we're up against, we can fight back. Thanks for watching. If you're looking for more information, feel free to check out base2s.com.